Welcome to the second edition of International Science Week. Here we group up two teams from different countries and make them work with each other to design a robot and on the theme of science for peace and development. Let's meet our team today.
Team SM Tech 10.0 is part of the St. Mary's Robotics Club, Pune, India. We are a team of 9th, 8th and 9th graders and are thrilled to collaborate with Team Xeo Academy for this event. We look forward to participating in more such exciting community outreaches during our journey in the world of robotics.
Our team comprises Aprajita Banerjee, me, Candice Rocha, Hargun Natharu, Jaydev Ranade, Kashika Chopra, Roxanne Framrose, Shivani Deo, Tanvi Acharya, and Varun Kadapatti.
We are a team from Romania setting foot for the first time in the world of robotics. Therefore, in the beginning of our journey, the Xeo Academy team is delighted and grateful to have the opportunity to work on an international project and is looking forward to taking part in future challenges.
Our team members are Adi Pastiu, Alex Fer, Ana Cibu, Anda Santeiu, Ariana Stoia, Carmen Oprinescu, Daniel Bogdan, Daria Julia, Diana Diacu, Dragoș Popa, Maria Cinezan, Mihai Weinberg, Olesia Ranca, and Tibi Oltean.
For this year's World Science Day, our teams, Xeo Academy and SM Tech 10.0, collaborated for creating a robot to draw attention to the importance of science in our lives. Because teamwork is very important, especially in this field, we all came up with different ideas until we settled on one, and now we would like to present to you the results of our work.
Before we explain the process of decommissioning, we must first understand what a nuclear power plant is and how it works. In a nuclear power plant, neutrons collide with uranium atoms, splitting them. The neutrons released from the uranium then collide with other atoms, causing a chain reaction. The fusion of uranium atoms releases energy that heats water to about 520 degrees Fahrenheit. This hot water is used to spin turbines connected to generators producing electricity.
How is decommissioning done? Decommissioning involves many administrative and technical actions. It includes all cleanup of radioactivity and progressive demolition of the station. Once a facility is decommissioned, there should no longer be any danger. There are two ways to do it, but both of them require humans' lives coming in contact with dangerous radiation. Usually companies combine the two of them, but that's still not the best idea. We thought of designing a robot which brings us closer to automatizing the whole process.
Right now, individuals are directly involved in the process of decommissioning, meaning they come in contact with toxic radiations. Human lives are in danger because of these nuclear radiations. It is a lot safer for a robot, which can be controlled remotely from a distance, to take their place on field. Though the decommissioning process wouldn't be 100% automatic, it takes away a big part of the risk.
A difficult part of decommissioning the nuclear power plant is breaking open the concrete shield encasing the reactor core. It has to be done carefully without allowing the concrete to fall inside the core. Our plan was to design a robot that can break the concrete shield using the method of hydrodemolition.
Hydrodemolition is a concrete removal technique which utilizes high-pressure water to remove concrete as well as asphalt and grout. Unlike jackhammers, hydrodemolition does not produce vibrations throughout a structure and therefore does not create microfractures, which may lead to a decline in structural integrity over time. This is especially useful in the case of nuclear reactors containing radioactive material, which may leak out through unsealed surfaces. As nuclear power plants require large quantities of water to slow down the neutrons, most of them are near a large body of water. So it's efficient to use water which is readily available for this purpose.
Hydrodemolition creates low dust pollution, reduces noise pollution, and the water used during the process can be collected after use. Recent innovations in technology allow us to clean and reuse the processed water after hydrodemolition. This is useful especially when there is no fresh water access for feeding the high pressure pump. We have thought of having an intermediate water storage which will be connected to the robot.
All hydraulic machines are basically the application of Pascal's law of transmission of pressure in liquids, which basically states that pressure exerted anywhere in a confined liquid is transmitted equally and undiminished in all directions. The principle of every hydraulic machine is that a small force is applied on a smaller piston, and that force is transmitted to produce a large force on a bigger piston. A hydraulic lift is a type of machine that uses a hydraulic apparatus to lift or move objects using the force created when pressure is exerted on liquid in a piston. This force then produces lift and work. The main components of a hydraulic lift are a piston within a cylinder, also known as a ram, or reservoir or tank, pump, a motor, which is used to drive the pump, and a valve. Hydraulic lifts, also known as hydraulic jacks, work on a basic principle. To go up, a pump pushes oil into the cylinder, which therefore pushes the piston up, which helps in pushing the car, therefore making it move upwards. To go down, the valve opens and oil is allowed to flow back into the reservoir and is pushed back using the gravitational force of the lift car. We are using a hydraulic lift in our design as it is stronger than and can carry more weight than a linear slide. When the robot has to cut through the cement, the lift raises the water jet to the height required at which the cement has to be cut.
After breaking the concrete, we had to figure out a way to move it. After considering a few options, we decided to manipulate the concrete using vacuum lifters, which are also used in construction. The principal components of a vacuum lifting system are first, the vacuum pump, which creates the vacuum to suction onto the concrete. Second, the vacuum reservoir and valve, which provide vacuum in the event of a power failure. And third, the vacuum pads, which are suited to the material used, in this case, concrete.
The benefits of vacuum lifting versus conventional methods. Vacuum lifting eliminates the need for unsafe and time-consuming lifting mechanisms such as hooks, slings, or chains. There is less downtime between lifts. It can lift materials without displacing adjacent pieces. It creates a powerful positive engagement of the loads. Example, hooks, slings, and chains can shift or come loose, which endanger the employees working there. Vacuum lifting systems are also able to go where people should not go. How the vacuum lifting works. The vacuum pump maintains a constant vacuum in the pressure reservoir. When activated, the system pulls a vacuum between the pad and the object to be lifted, in this case the concrete, providing a powerful positive seal which holds until the operator activates the release. This works even in the event of a power failure, and it can be operated remotely, which is a great advantage here.
This is a model of the bot we designed in the CAD software called Onshape. There's a vacuum attached to the side which does the job of displacing the cement surrounding the nuclear core. At the base, there's a hydraulic lift to adjust the height of the bot. There's also a hydrodemolition system attached to the side to cut through the cement, and at the top, there's a camera and antenna placed for communication echo, allowing the human working the reactor to control the bot while being a safe amount of distance away. For mobility, the bottom of the hydraulic lift has a set of triangular track wheels. In our design, two identical bots work simultaneously by first cutting a vertical line, splitting the cement into two large pieces, and then pulling them away from each other at the same time with the help of the vacuum.
Controlling the machines in the power plant remotely from computers would help with protecting the humans working there from the radiation. This idea came to us while discussing our main part of the project, and it also has to do with programming, so we thought we only mention it as a bonus.
I would like to thank Team Xeo for arranging this event and giving us this opportunity, and Team Xeo Academy for being our partners and teaching us how to collaborate and interact with each other across vast distances. The help and support we've received from our respective organizations cannot be overstated. A special thanks to Mr. Sanjay Phadke for giving us the invaluable information about hydrodemolition, which was pivotal in the conception of our design. This journey has not only been memorable and enjoyable, but also a valuable learning experience. Thank you.
Okay, that was sincerely left me speechless. Great work, great idea, an idea that I really hope someone could see and actually try to implement this, because I really think it would work. And it's just sums up the need for good ideas and for ideas made for people and their safety, because we simply tend to ignore safety sometimes, but this is really something that we should think about and actually start working more towards achieving a better world by being safer, which seems a little bit comic in this situation, but yeah. Well, that was great. Thank you for joining us. Thank you for taking part in this project. This was great. And we really hope we'll actually have you join us again next year, maybe for the third time in a row. So with this, sorry.
No, it's okay. I'm sure next year also we will be here to keep this up.
That's great. So with this, we'll end the first day of the International Science Week. Hope you had a great time, and we'll see you tomorrow.